Yeah, good day. You're welcome to another edition of our class. And today we'll be talking about solar panels. Right, let me clearly solar panels. Now, there's a couple of things you need to consider before choosing the kind of panels for any project. Now, you need to look at the types of PV you're talking about. This is the monocrystalline. Sorry, let me make a monocrystalline, right? And polycrystalline kind of panels. Most times we always take them as the mono. Most of us in the field will always say either the mono or the poly. Instead of calling maybe monocrystalline, you just get to the market, you say you want the mono or you want the poly. Well, that's just the lame word, but whatever it is the monocrystalline and the polycrystalline. Now, you hear the word most times, photovoltaic. Photovoltaic has to do with where, should I say, is a kind of device. That's what solar panels are, that convert light energy from the sun to electrical energy. These are done with, because of the way your solar panels are designed, these panels help in converting light energy into an electrical energy. But these energies, they may come, when during the conversion, it comes in bits which are added. So the conversion of light energy even to electrical energy, it is done through the help of, I don't know if you've seen PVs before. When I say PV, I mean photovoltaic panels. Let me get one sample. Sorry, just a moment, please. All right. Okay, this is exactly what PVs they look like. For this is a monocrystalline kind of panel, right? Now, how do you identify a panel that are mono? You see this kind of diamond shape in between them. You see, you have this. But if it's the poly kind of, you see, most times they're always blue, just all through straight lines. You don't have this diamond shape on them. So that's how you know the poly. But now, today we're considering how you consider panels, your PVs, for installation. Now, the best type I will always advise anytime for, especially this part of where we are, is the mono crystalline kind of panel. They are much expensive. You should note that they are much expensive and they are more efficient. Unlike the polycrystalline, it is cheaper anyway, not as effective as a monocrystalline. And I will always advise, by the time you're trying to choose a particular panel for any project, please always make sure you don't mix this together, the polycrystalline and the monocrystalline. Why? Because at the end of the day, if you, for example, using your charge controller, maybe using a PWM, okay. I hope I'm not moving too fast when I say PWM. This is a pulse width modulation kind of charge controller. You use if you're using this by the time you're having this kind of these two types of PVs for your installation, what it does is most times your panels will most times try to track the lowest voltage, the least of them all at any time. And since this is more efficient, but at the time it's trying to pick power from the sun, it may want to flow at the frequency in which this is operating, the voltage you have because the lowest point, this is where, because voltage tends to flow from the high to the low, and when it gets to this low, this is the point it may want to pick, not able to pick this other one. So mixing panels might not be the best option for any installation. You want to do any installation, make sure your PVs is either you stick to the monocrystalline or the polycrystalline. But I will always advise anytime you stick with this, the polycrystalline. It is very efficient. Now, you have an installation, you're thinking of, okay, what do I need to calculate for? You need to calculate, number one, you just need to calculate, number one, the load of of the, should I say maybe the, I might say load of the house. Do I use the house or load, or should I just say load alone? If I say calculate load, that is, if you're considering this, you need to know, okay, fine, what is the size of equipment you have in that establishment that your solar panels will be powering. So it will now, this will now determine the size or the capacity of the, what's the name, the PVs that will be incorporated into this. Also, you should also consider, number 2, the type of charge controller. Very important. The type of charge controller is also very important, and the capacity of your charge controller. Now you must understand that there are different capacities of charge controller. We have charge controllers that are maybe 60 amps, all right? We have the 60 amps, you have 40 amps, we have 80 amps, you have the 100 amps, and we also have different, should I say, types of charge controller. We have, the, like I said earlier, the PWM and the MPPT. So these are, I think we'll still have to talk about this, the charge controller, as a topic on its own. But today, I might just brief a bit why I'm talking about this. Why? The MPPT, maximum power point tracking. Maximum power point tracking. This is one of the best kind of charge controller for any installation. The MPPTs. These are the best for any installation. I will always recommend this for anyone, especially when you're having a big capacity of load that you want to operate, that you want your maybe your solar inverter, your charge inverter to always power. You need this. This is the best for that. I will tell us this more about this when we start talking about charge controller. Then also we need to calculate, we need to look out for number 3, the size of the inverter. Now, this should be proportional, directly proportional, the load of the house and inverter, because by the time this is increasing, this is also increasing. All right. If we're having load, if the load of the house is increasing, then it means the size of the inverter will also increase, so as to be able to, should I say, efficiently power all that you have in the house. And make sure the size of the inverter must always be bigger than the load. All right. Take for example, if you have a load, maybe by the time the load of the house has been calculated, let's say we have you check the size of the load. Maybe you have total here, we have maybe should I say 5,000 watts as the total load in this house, right? 5,000 watts. If you calculate it for your inverter, you should be looking at nothing less than 7,500 watts. Now, if I say watt, it means if you say 5,000 watts, this is also same as 5 kilowatts for the inverter side. This is a 7.5 kVA inverter. So it means if you're having a 5,000 or 5 kilowatts of energy needed, right? 5 kilowatts of energy needed, you'll be looking at 7.5 kVA inverter. You'll be needing, okay, if you're using the 5,000 watts, you'll be looking at 750 watts for your inverter. So you have a plus minus to be able to carry cater for extra load. Like for example, the starting current of your ACs most times is always different from the operating current, so it needs more for it to start. So these are the kind of things you need to watch out for. So for your panels, I will always advise, when picking your panels, please always try and go for new panels. Why did I say so? Every of these panels, they have efficiency that with time it begins to drop, right? the capacity, the functionality tends to drop with time, with usage. By the time, maybe the lifespan for most panels is 25 years. So, and you go into the market, you want to buy, and you decide to go buy maybe a fairly used panel, you don't even know how many years they've used it. At the end of the day, one thing you should understand, with time, it begins to drop the efficiency of that panel. So I will always advise, when you're picking panels, always go for new panels. It is better, it saves a lot.
Assets, no place for the unknown. Defotech, the shield I need. From hackers to intruders, plating the scene. Defend the tech, keep my home secure. Defotech on the case, that's for sure. From cameras to alarms, they got it all. Protecting what's mine, standing tall.